So 12.6 is next, and it's still talking about surface area, but it is specific to surface area of a cylinder. So they've broken this away from triangular prisms and rectangular and square prisms and made an exercise for itself because it's a little bit more detailed. It gives a specific formula. All right, so first of all, we want to think about what a cylinder is, and we talked about it a little bit in the last video and showed you in the textbook that a cylinder, well, an example might be your tin of spaghetti, tin of whatever you want to write there, of course. But basically it is a round, I want to write cylindrical, but I can't do that. So we're going to say a round prism with circle at top and bottom. Okay, very, again, non-mathematical way of writing, but hopefully something that you would understand. All right, so let's have a look at this. So you should be copying this, please. How would we find the surface area of a cylinder? So this is what I was just talking about, okay? And the only things you need for your surface area of a cylinder, if you look at the one on the left, you need the height, so how tall your tin of spaghetti is, and you need the radius in the circle. If you have these two dimensions, you can work it out. You're given a formula, but let's work out how we get that formula. If I was to get some shears, cut a length from top to bottom of the circles, and some beautiful machine stretch out what is here, it would look like this. And this thing here is called a net. So a net is something that comes from, or that is flat, so it's 2D. And just pretend you had, if you were in year 7, you might have this on a big sheet of cardboard, and we'd get you to cut it out, and you'd wrap this around the top of the two circles, try and glue it together so it looked like your tin of spaghetti. But if you were able to crush it out and make it look as a net, you would find that you would have a rectangle and two circles. So the circles are okay. We know about them because we know that the area of a circle now is pi r squared. So you'd have a pi r squared there because we're talking about area, remember, and a pi r squared down here. How do we figure out what this is though? All right. We know this is the same as this bit here, so we could say that that's the height. How could you say what this is? And if we're in class, I'd want you to really think about it, okay? Now, this length, thinking while I'm talking, how could you work out what that is? It's part of a formula. Think about this line. All right, this line is going to be the same as this. Because if you were in year 7, you cut it all out and you put it together as a cylinder, this would go all the way around to here and this would go around to here. So this length here is the circumference of a circle. So the green part, we can say, is the same as 2 pi r. Okay, so let's have a look again quickly about what we've got. We've got, because we're talking about area, we've got a circle, which is 2 pi r, another one, 2 pi r, a height of h. Remember, we don't have any numbers yet. We're just trying to find the formula. And this line here, which corresponds with all the way around the circle, which we know to be circumference, and therefore that must be 2 pi r, which is where I got that from. Okay, so hopefully you can see that. It's very hard with me not staying in front of you showing you this, which is what I would normally do. But let's have a look now at what that means as a formula, because some of you will just now go straight for the formula. The surface area, one circle is pi r squared, which is here, but we have two of those. So it's 2 pi r squared, that's 2 circles, plus, now this rectangle must be, what's this rectangle going to be? It's going to be, we know rectangle is width by height, so it's going to be 2 pi r times height. So the area of this rectangle is 2 pi RH, which I've written here. Now to make this look nicer, what's the common factors in here and here? Because we're going to take them out. So there's a 2 in both, so that goes there. There's a pi in both, that goes there. And there's a 1r in both, so that goes there. Now 2 pi r times what gives 2 pi r squared? It's an r. Put down your plus. 2 pi r times what gives you 2 pi RH. So in other words, what else is left here? It's an H. Okay, so I've made that look a little bit messy. What you need to remember is this magnificent formula. Surface area of a cylinder is 2 pi r bracket r plus h. Put a big circle around that because that is way important. Now, once you know that, you will be absolutely fine. And you can write that down every time. And I'll show you why it will be fine. Just copy this out. Press pause if you need to. Okay, so having a look here, we need to know the radius and the height. That's all you need, and then you can work it out. So radius in this case is 2, and our height is 3. And our formula is 2 pi r bracket r plus h. So we're going to go ahead and we're just going to substitute the r and the h in. So we're going to have 2 times pi times radius, which is 2, times inside the bracket, radius, 2, plus height, which is 3. All right, so now we're going to do, we can do outside this bracket. So 2 times 2 is 4. So it's going to be 4 pi multiplied by, inside the bracket, 2 plus 3 is 5. Okay, now 4 pi times 5. You could put that straight into the calculator, or you could do 20 times pi, or 20 pi. And hopefully you get 62.8 meters squared. Now, if you get trouble from here to here, that could be the way you're using the calculator. And don't forget, if you get a value of 20 pi and it just stays 20 pi, you need to press this button here. So above the enter, below the plus, these two arrows will put it into decimal places for you. And if the question doesn't ask, then you should put 2 decimal places. Okay. All right. So really, it doesn't get any harder than this. So this is the whole exercise. So I've got another one here for you. And we're just going to have a look. So the radius. Now, this time I've put it on its side. So that's pretty much the only difference. And I've given you the diameter instead of the radius. So we want the radius. So if the diameter is 1.4, then we want half of that for the radius. So the radius is going to be half of 1.4. So you can do in your calculator, if you can't think in your brain, 1.4 divided by 2. And hopefully you get 0.7. The height is given to us from the actual picture, which is 1.5. All right, formula as it was before, 2 pi r bracket r plus h. So let's plug it all in. 2 times pi times radius is 0.7 times in the bracket 0.7 plus 1.5. All right, 2 times 0.7. We know that's 1.4 pi. Multiplied by 1.5 plus 0.7 is 2.2. Now, I'm going to go straight into the calculator from here, showing you that it can be done. I really need you to be doing it too, because imagine if you can do all that, that's the hard stuff, and then you mucking up what's in your calculator. Okay, 1.4 pi multiplied by 2.2, enter. I get 9.676, so 9.68, and it's meters squared. And I go back straight away and check it because I might have made a mistake. 1.4 times pi times 2.2, 9.68 meters squared. Yes. Now, I can't show you any more than that because that's all this is in this chapter. So again, you're going to have time at the end to work on your task. it is not time to say goodbye. It is time associated with that, which does need to be handed in. All right, so let's have a look. 12.6, 2A, B, C, D, F. So 5 straightforward questions. Then we have question 4 and 5. In question 4, I think there's something like 3 different cylinders, and you have to work out which is the greatest surface area. So it's like 3 questions in that. But as you can see, it's still less than probably 10 questions. All right, so that's your first thing you want to do. After that, you need to continue working on your task. Please come back in and ask me where that is, when it's due, how you submit it, all that stuff, because it's not something that you can just dismiss and not do. Excellent, thank you.